Hi, welcome to Fun Science with Rohini. In these videos, I'm going to narrate folklore of science. Yes, folklore of science. They are legendary stories about scientific discoveries, and I would like to name them an inspiring moment that changed everything, the Eureka moment. I would like to begin today's video by narrating the Eureka moments of two scientists, Archimedes, the one who was responsible for the term Eureka, and Newton, how an apple changed his life. Once upon a time, in Syracuse, Sicily, there lived a great philosopher and scientist, Archimedes. He was very close to the king, and he would often visit the king. On one such visit, the king, hero of Syracuse, gave him his gold crown and asked him to see if it was made of pure gold without melting it or breaking it in any way. Now, this was a big problem back then because weighing scales were there. People could weigh things, and most precisely, with precision. But they did not know about anything else about finding out the volume or density. Now, Archimedes was in a fix. He did not know how to see if the crown was made of pure gold. He thought and he thought about this problem for a very, very long time. And he thought about it so much that he thought about it in the morning, at noon, in the evening, and even at bedtime. And he didn't find a solution. He carried the crown everywhere with him. And then one day he carried it into his bath. He put the crown on the floor of the bath and he was getting into his tub. He undressed and he got into the tub. And then when he was immersing himself in the tub, he noticed that when his body is immersed, an equivalent weight of water rose up. So he immediately shouted, "Eureka!" meaning "I have found it" in Greek. And then he repeated it again. He immersed himself, he dipped himself in the water, and whatever part of his body was dipped in the water, that amount of water rose up. And he again is said to have said, "Eureka, Eureka." And he immediately came up with a technique to measure the crown and understand if it was made of pure gold. So in his excitement, he ran to the king as he is undressed, naked, on the streets of Syracuse, Sicily, to meet Hero, the king of Sicily, to tell him that he has found a technique. And then he put the gold block of equal weight of the crown. He took a gold block which weighed exactly the weight of the crown, put it in water, and observed how much of water it displaced. Then he took the crown, he put it in water, and he observed how much of water it displaced. Now, if the crown was made of pure gold, he surmised, that means he thought, that equal amount of water should be displaced by the gold block and the crown. But like Hero suspected, the king suspected, his goldsmith stole some of the gold and mixed equal weight of silver. So the weight was the same. The weight of the crown made with the gold block, the weight of the gold block and the crown were the same. But the amount of water displaced by the impure crown was different compared to that of the pure gold block of equal weight. And then came up the principle of this is not the principle of Archimedes. This is the great Eureka moment of Archimedes, and this happened in 230 to 260 BC. Archimedes lived during that time, and it happened at that time, and this is the Eureka moment. Archimedes is responsible for coming with the principle of flotation or buoyancy and understanding how ships float and all that. But this always is the folklore of science. Now I will tell you another story which has become legendary or which is equal to the lore of science about Newton. You must have heard this a lot of times, but the experiment with which it is related may not be known to many children. So therefore I picked this. The year was 1966. The year was 1666, 1666, and there was plague. And because of the plague, all the universities, all the activities were shut down. And Newton, who was in Cambridge at that time, had to go back home to Lincolnshire, his mother's place. So Newton packed everything and he went back to Lincolnshire. And at that time, he was working on the problem of how moon moves around the earth and how moon orbits in that same orbit. He was working on the motion of the moon around the earth and the orbit of the earth. He thought about it. Like all scientists are always said to be obsessed with their idea, and probably it could be true because all the lore says the scientists were so obsessed with the idea that they had flashes of an answer in situations. So Newton also was taking a stroll in his mother's garden, and he kept thinking about this problem when he saw an apple fall. Many say that the apple fell on his head, and some folklore says the apple hit him on the head. But there is no record of apple hitting him on the head, so I will stick to apple falling down. He saw the apple falling down. And that moment when the apple fell down from the tree to the ground, an inspiration struck him. And he said, if the apple falls to the ground in a straight line, perpendicular always, and doesn't go upward or doesn't fall sideways, it can fall anyway, right? Like a flying feather or something. It falls straight down. It doesn't waver from its path. So he thought, if it always falls down in a perpendicular line to the earth, there must be some power in earth which is pulling the apple down. And because the apple is always falling straight down, the power must be located in the center of the earth. And this, as you all know, he named it gravity. And then he came up with the idea that if earth is pulling the apple down, earth is exerting some force on the apple, apple also will exert a little force on the earth. And he thought that this force, this gravity, need not be limited to small distances or to some particular distances. He thought that it can probably go as high as the moon. And he thought that the gravity of the earth, or the pulling force, pulling power of the earth, is also experienced by the moon. And it determines the moon's movement around the earth and the moon's orbit. So, a fall of an apple gave us the theory of moon's movement around the earth and it staying in a stationary orbit because it's being pulled